problem up on the board. It's number 48 from your text. Tan squared alpha plus 1 over secant alpha equals secant alpha. Okay. So, I'm going to again suggest that you pause the video and try to work this one out. When you come back, I'm actually going to do this two ways to sort of illustrate that not everybody thinks through these things the same way. Okay. So see if you can work it out. Welcome back. Okay, so this is my left-hand side. This is my right-hand side. This identity just involves tangents and secants. And I know tangents and secants have something in common. They both have a cosine in the denominator. So I know that there's a Pythagorean identity that gives me a relationship between tangent squared and secant squared. If I'm remembering that and I see a 1 and a tangent squared, might think this is relevant to that Pythagorean identity. Okay. So, if you remember the Pythagorean identity, you're golden. If you don't, that's totally fine. All you need to know is how to get there. So, you do need to know your basic ones. Sine squared plus cosine squared is equal to 1. And then from here, since secants and tangents have cosines in the denominator, I'm going to just divide everything through by cosine squared. So now sine squared over cosine squared, that's tangent squared. This is 1. And 1 over cosine squared is secant squared. So I just did a little bit of side work here to remind myself of this version of my Pythagorean identity. Again, some of you might remember that without having to derive it. Some of you might be motivated to sort of do this side work. But now this is great, because I can say the left-hand side is tangent squared alpha plus 1 over secant of alpha, but that's secant squared alpha over secant of alpha using this Pythagorean identity. And now I can cancel one factor of secant of alpha, and I get secant of alpha, which is the right-hand side. Nice. So there, this went pretty quickly if you happen to notice that Pythagorean identity. Very nice. Okay. But you might be saying, you know what, I never would have thought of that. I don't like working with tangents and secants. I always switch to sines and cosines. And that's totally fine. So I'm going to do this problem again, and I'm going to switch to sines and cosines, because that's my go-to if I don't see something else. So in this case, I did see that. I would have done it the way I just did. But in other cases, I might not see something like that. I'm always going to go to sines and cosines. So if I did it that way, I'd say the left-hand side is tangent squared becomes sine squared over cosine squared plus 1 all over 1 over cosine of alpha. So now I'm dividing by a fraction, so I can flip and multiply. So this is going to be sine squared alpha over cosine squared alpha plus 1 times cosine of alpha. If I want, I can write that as cosine of alpha over 1. So now I'm going to distribute that multiplication. So I'm going to get sine squared alpha over cosine squared alpha times cosine alpha over 1 plus just cosine of alpha. And here I can cancel one factor of cosine. So I'm going to get sine squared alpha over cosine of alpha plus cosine of alpha. Okay. Now, if I take a look at where I'm trying to get, I could stop here if I wanted to, but if I take a look at where I'm trying to get to just one term. I've got two terms, but I know how to add fractions. So I think I'm just going to write that cosine alpha as cosine alpha over 1. I'm going to get a common denominator multiplying by 1 in the form of cosine alpha over itself. So that way, I've got sine squared alpha over cosine alpha plus, now on top I'm going to have cosine squared alpha over cosine of alpha. Once I have that common denominator, I can write this as one fraction with a cosine of alpha in the denominator. On top, look at that. Sine squared plus cosine squared, which I know is just 1. So I can say that's 1 over cosine of alpha. That is secant of alpha, and that was my right-hand side. So it maybe took a little bit longer this way, but if this is what's more comfortable for you, I'd much rather spend 5 minutes feeling comfortable with what I'm doing than 30 seconds feeling like, am I doing this right? Is something wrong? Blah, 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 blah. So whatever method feels more comfortable to you is what you should go with. Okay.